Right, welcome to another video, and in this video we'll be learning about charts and charting techniques. As data analyst, it is important. Now this is beyond Excel using or Excel users. Now if you are a random Excel user and you're opportune to see this video, then this will actually upskill you, make you more better and efficient in your place of work. Okay, so this is beyond just using any random chart to describe data. You want to understand which data, which chart should be used to communicate which kind of data. Why is this important? Like they say, a picture is worth 1,000 words, right? So that means that if you have a large data and you want to communicate this to non-technical people, now as a human, the large data can be intimidating, can be confusing, it can be a lot, it can be overwhelming. Staring at a large spreadsheet, all right, you just have data everywhere, but you want to be able to simplify it, show summaries of what you have done so far, right? And charting is one way to do it, using charts or graphs. Okay, I think I should use both words interchangeably. In some part of the world you might be used to graph, in some part of the world you might be used to chart, so I'll just use both words interchangeably. Now I want to learn which chart or which graph is best for a kind of data, right? Which chart or which graph is best for a kind of data. And this is important, so we don't just do things like newbies, right? Don't just use charts because it's fine, it is beautiful, I like it. We don't use graphs for aesthetics, okay? It has to communicate something, because whatever is irrelevant in our reports, whatever is not useful, whatever is not communicating an insight should not even be in our report, okay? So it is important to understand how to use the right chart for the right data, okay? So let's just jump into it without waste of time or further ado. The first one we'll be looking at is the common bar and column chart. I mean, this is a chart you literally see almost in any visualization report and all of that. You just see bars. Sometimes you can see a report that, and all you have there is just bar charts. If you see another chart at some point, you can tell that this person just had to maybe just squeeze it in, just doesn't want to keep the generic bar chart and all of that. So how do you make your reports? Of course, if all your data has to go with bar charts, no doubt about that, but the question is, do you really know if they are supposed to be for a bar chart, or you just feel, okay, I think this is what I know how to use, or this is just simple, right? Of course, simplicity is key. The highest form of or the best form of complexity, right, is simplicity. Just simplify things. That's the best thing to do, okay? So yes, but the major thing is, do you have the right knowledge for the chart to use? Bar and column charts, what are they used for? What are the best use cases for comparing? Of course, this is just a note put together. English can vary, grammars can vary, right? But you have a picture or an idea of what it is. Okay, bar and column charts, best for comparing categories or groups. Example right here. So, e.g., example, for comparing sales for different products or regions. So you want to see, maybe you have sales by products or sales by region. You want to see something like that, right? You can use a bar or a column chart. Now, what's the difference between a bar and a column chart? A bar chart is horizontal, as when something is lying on the floor, that kind of thing, right? Horizontal, a plane, straight line. While column chart is vertical, like a pole, right? Up to bottom, something like that, right? So that's the difference between a bar chart and a column chart, okay? Now, when you use a bar chart, when you use a column chart, best use cases, use a bar chart when the category names are too long. So you don't want to have your audience tilt their head, bend their head, they're trying to read your x-axis. Oh, okay, that's date, or which date is this? And then they're bending their head literally to see what you have, right? That's not cool enough. So you just switch up to a bar chart, right? And sometimes when you have too many categories, the bar chart can also do a good job. When you have it too long, it can do a good job. Instead of having it spread out vertically, it can spread down horizontally. Okay, so column charts, great for comparing data across different categories over time. Let's say monthly revenue by products. You have, and this is not a continuous date in this case, not a continuous date in this case, more like you have January, February, static, month names and all of that. Column charts can do what a bar chart will do. The only time you switch to a bar chart will be, oh, the names are too long, the categories are too much. Okay, and stacked bar charts, that is where you have proportion. It does something similar to what a pie or a donut chart will do. Okay, so of course we have different data to explore all of these different kind of charts, and we'll do that. So let's just go through all the notes here, and after we're done with the notes, then we'll start exploring the charts one after the other. The next one is the line and area charts. This is ideal for trend over time. Anything that has to do with trend over time. Trend over time. Okay, trend over time. Don't forget that. So that means it is certain that a date will be involved, right? On the x-axis, you'll have a date, a continuous date, not like the one mentioned just right here, where you have the month name and so, right? You have a continuous kind of date. It could be year, it could be month, all of those things like that. All right, so you have trend over time. Now, example for tracking monthly sales or stock prices over the year. Now you have they literally do the same thing. Okay, literally do the same thing, but just like a hedge case, or that's the word, or a use case, right? Where you have to use bar instead of column. The same time when you want to use area, it should be for something cumulative, right? So you can go for an area chart. A pie or donut chart, of course. It's amazing how two edibles are combined for chart names. So pie, donut, okay. So it shows parts of a single data series. It shows the parts to whole. Now, what are the keywords you should take note here? You want to take note of things like, hold on, just hit tab. Okay, yeah, I can do that. Let me see if I highlight. Yep, I can't. Okay, I have to tab everything. Okay, I'll just do that myself. So what are the keywords for you to note? Parts to whole, ratio, percentage, share, proportion, right? Proportion. So these are the keywords that you might want to take note. Okay, these are the keywords that you might want to take note of. Just make that gray. This kind of gray. Okay, this gray is fair. Yeah, this is fair. All right, so these are the keywords you should take note of. Anything has to do with part to whole, the ratio of something to another, percentage, share, proportion. Right, those are the keywords you should look out for. For example, displaying market share of different companies. That's when you can use the pie or donut chart. What's the use case for a donut? When you have, let's say, for example, multiple categories. For example, you're showing the share of different companies now over, let's say, 2-3 years, right? It can help you nest them inside one another, or one another, more than two. Yeah. Okay, that's that about pie or donut chart. Now we have histogram. Histogram displays frequency distribution of a continuous data. Let's break it down. Okay, what is frequency? Occurrence or recurrence of something. How many times something happens? Often, right? Okay, now distribution. And consider distribution in this context. A better use of what could be categorization. Okay, frequency grouping. That means for those who come 2 times in a week, let's say it's an attendance, they are grouped into a class of 1 to 3 days per week, or 1 to 3 times per week. And for those who come more than 3 times, they are grouped into a class of 4 to 5 times per week. So that's frequency distribution. So you can see it oftentimes, the grouping of how many times certain people come. So you group them. Oh, these people, I think they are in this class. I think the best example would be school grades. You have A's, you have B's, right? You see, based on the score range, people fall into the class of A, class of B, class of C. Do you understand? So that's the distribution. Something like that. Okay. So we can now see how many people are in the class of A. Because the score range will be, let's say, 100. Oh, okay, should be minimum to maximum. So let's say an 80 or 75 to 100, and you see the number of people falls into the class of A, right? So that's the idea of histogram of frequency distribution. So for example, you can show demographics, like you want to see the age range of people. You want to categorize people by age range. For example, you can say, okay, teenagers, that's certain age, that's 13 to 19, right? You can say youth, you can say adults, you can say senior citizens. No, those are frequency distribution. Histogram can help you do that easily. Okay, now waterfall chart is a very good chart, and if you have a good hang of it, it can be a good storytelling and effective kind of chart. Okay, it shows the cumulative effect of sequential, notice the word sequential, or progressive profit or loss, cost or expense, gain, or no, use any word. But of course, it will make more sense to you when you see it practically. Okay, so it will make more sense when you see it practically. We'll use some examples, then you see, oh, okay, this is what is going on in there. Right? For example, visualizing an initial value, for example, the profit is affected by gains and losses over time, right? Or for example, let's say trading account, initially there was a deposit of, let's say, $10,000. So after a certain time, maybe after the first trade, there was a negative value of 2,000. Person lost 2,000. Then after that time, there was an additional 5,000. You see the cumulative steps sequentially. You see it that way, right? Which is a very nice thing to use. Okay. Now, radar chart. Radar chart is also a good chart. I see it as a kind of chart that it's persuasive, not if it's I don't know if it's safe to say it's not so analytical, but it is quite persuasive, and it's a very good chart that can help you simplify much data. Is that the word? Okay, let's just leave that till we get to the example, right? We use another kind of chart, and then we'll see how radar chart does the job better, something like that. Do you get that? Okay, so that's what we're gonna do. Now the next thing is the combo chart. Okay, combo chart combines two or more charts. That's the word combo. Full meaning could be combination. Okay, so you're saying you want a bar chart and a line chart, the most common kind. Okay, so let's say you want to see the profit and target, sales and target, sales and profit margin, etc. Cost and expense, or cost and net profit, things like that. You want to see them. You want to see, okay, based on the cost, like when we have more cost, do we have higher profit margin? Do we have more profit? Or whenever we have lesser cost, we have more profit. Just a combination of chart that you can see together on the go that way. Right, very nice. And scatter plots, I intentionally left it last because we'll have to look at some other things again, right? So it shows the relationship between two variables. Okay, when we get there, we'll explain some more things about scatter plots. Okay. Of course, example, height against weight. This is a natural phenomenon. Okay, natural phenomenon. All right. So this is what we have. These are quite common charts you see in. Of course, we have maps and other things, but we'll not be looking at that in maps. Are obvious. You want geographical location of things, and I just get it done that way. Maybe in other visualizations, so like Power BI, of course, it's something we might want to consider in Tableau or whatever it is. By the way, if you're a Tableau learner, I have a playlist for you in the same channel. Just I think it's Tableau or something. Yeah, I'll just add the link in the description so you can easily go through the videos for Tableau. Quite some good videos there for you to learn from. All right, so these are the charts we'll be considering for Excel in this video. Of course, I still have a tip of the ice. No, is it icing on the cake? Something like that. All right, let's jump into it and get started. All right, the first one. Now we have, oh, okay, that was supposed to be int, H-I-N-T, not bad. All right, int. I want this to be this way. Okay, so the first one, which is category comparison. Now we want, okay, no, not this names, the long product names is the product names that are long. I see that. All right, long product names, and then we can do region versus sales. Since those charts are not too okay. Now this video might I always do it in 3 parts before, like after this, then we'll stop that, then we'll do the visualization. But I just feel I'll do the 2 together, then we'll keep the charts there. So in another separate video, we'll now look at formatting the charts. Okay, we'll now look at how to format the charts. It's very important. We learn how to use the charts, we should also learn how to format it. But this first one, we just pick all the charts that we want. Okay. All right, so this is what we have. And the first thing we want to do is we want to pick the product. I'll hold control because I want to do product and sales. Okay, so I'll hold control down on my keyboard, then highlight monthly sales. So I've been able to leave the region out of my out of the equation. Let's just keep it something simple like that. So I'll go to insert and recommended charts. Of course, I already know the charts to use, but sometimes when you come here, you have the list of all your charts. You just go to all charts, then pick whatever it is you want. Because at some point, let me escape this. At some point, if we come here and we'll try to pick some charts, eventually we'll not be able to see all our chart directly. But of course, you can just pick what you want from here as well. Okay, whatever works for you, man. Or people, ladies. Okay. So this is what I have here. I think I'm going to use this, right? The bar chart, the column chart, I mean. So you can see now we have a column chart. Plus that column chart, that's what it's called. Now, remember, long names, you use what? You use bar. So you don't want people bending their head like this and say, oh, okay, laptop, phone, accessories, none of that. So what do? I can easily switch. And of course, we have a contextual ribbon, right? We have contextual ones that only appear based on a selection. If I click out, it disappears. Click back in, it's there again. So I'll go to chart design, and then I'll do change chart type, right? Now I can see all I have. So I'll go to bar, and of course, this is what I want. So I'll hit enter, and boom. You can see how nicely formatted this is now compared to what we have before. So this is better compared to what we have before. All right, so keep this somewhere. Can I make it smaller? I'm not messing things up. Yeah, still nice, all right, just keep it there. Now you can see the use case of long names. Bar charts does the good job for us, right? Nice. Now the next thing is region sales comparison. I want this guy to be this way. Yep. So now I highlight all of this. Okay, now since they're together, I have the quick analysis option, which is down here. It says quick analysis. Let me go back there. So it says quick analysis, Control Q. So I still feel it's almost the same as coming here, picking your charts, but whatever works for you, whatever is faster for you. But let's see how it works. I click on this, it displays all of this. I can do quite a number of things with this. It's a shortcut, not a shortcut, but a shortcut without a command kind of thing. Okay. So I want a cluster column chart. So since it's here directly, I'm just going to pick it. Boom. And you can see that this does not look messed up. This looks perfect because the names are not too long. And we have it this way. Right. So I'll reduce that somehow. Now when I reduce it, it's now looking messy. So let's see if we make it the same size as this. Probably everything will be okay. Let's see. All right. Not so bad. Not so bad. But I'll just increase it a bit. Yeah, for clarity. It's better this way. Nice. And the last one, which is stacked, is the region contribution per product. So I want to use the theory. I want to use all three now. I want to see how each product contributed to individual region. Okay, I want to see how each product contributed to individual region. Now this will look messy. Let's just pick something. More charts, so you can see it's the same as going all the way there. By the way, we'll still be exploring shortcuts. I will look at all some possible shortcuts that we can use, Coco stuff. What do we want to pick again? Stacked one, stacked bar chart, stacked. Okay, so this is what we have. You can see we have the question is regional contribution per product. So yes, that's correct. So hit enter. Let's see how that looks like. Of course, because the names are too long, it is supposed to make the names vertical for us, but it's not doing that. Okay, so this is what we have. Now, in the reality of it, what we should have, this should just be a single name, and then we have the regional contribution. No, we'll just keep it this way since we just want to see it. Now, this is not stacked. Okay, this is not stacked. So I just is that oops, not there. Change chart type. Stacked. Well, it's not stacking for me. 100% stacked. No, of course, the way our data is arranged is not letting us get the stacked feel, right? It's supposed to change that for us. Okay, supposed to change that for us. Funny how I didn't even think about the data structure I have for the stack bar chart. So just take this out. We'll use something under the pie chart for that. Yeah, we'll use something under the pie chart for that. Oh, why do I have something for donuts? Okay, we'll create that. Okay, next one, the line or area chart. And in the line or area chart, we have these two different data sets. And this will go for line chart. Okay, so do my quick analysis, click on charts, and of course I have charts here. I have the line charts here, so I'll pick it directly. And we can see the trend of those charts. We can see it's going all up. No, has been going upwards since the first month all the way to the 6th month. Right, so that is what this is giving us. So just bring that somewhere. It's too small. I know, let's just keep it there for now. Now that is as simple as using a line chart. Just select your data, or quick one, Control A, select data, then quick analysis tool, go to charts and select what you want, just like that. So this is what a line chart looks like. Let's make that bigger. Too tall, looking weird. Okay, we're just gonna leave it that way. Now the next thing is we want to get what's the word now? Line charts, area charts, yeah. So this is more like a population sensor. Okay, so we have this please note that these are just random numbers, random years. So let's just do 2021, the 20 to get 5 years, like 2021, right? Let's see. Let's drag that down to 2026. Oops. All right, a few series for me. Good. Okay, so we have up to this year. Nice. Now we want to put this into an area chart. So I'll click on this, go to chart. I don't have an area chart here, so I'll go to more charts, which is the same as going to insert. I'll click on recommended chart, select area. So I have this stacked version of it. This is a stacked version, but this is what I want. So I'll select this and click enter. And you can see that this is what we have. Now the only thing missing is we want our year on this axis, right? We want our year on this, and I know what you're thinking. Let me show you. This is probably what you're thinking. Do this, click this way, charts, more charts, this area charts, and okay. But see, the problem with that is that it has added this to our data, our series, but this is supposed to be this is not supposed to be part of our series. Okay, so what do? Chart design, select data. I will remove that from there, edit this, and bring this in, put okay, click okay, boom, just like that. Okay, so this is what we have now. This is what we have. Let me just keep that there. So we can see that in 2021, now there is a tricky part to this. Okay, very important that you understand it. If you look at Asia, the blue is Asia, right? There's about 7,000, and we have Europe. Where's Europe? 15,000, and then we have this guy about 31,000. So you must understand that this is a stacked. This is not a stacked bar chart. Oh, is this bar chart? Area chart. Okay, so the axis for this begins at 0. The axis for this begins at 0. 15,000 is somewhere around there. 30,000 is somewhere around there. Okay, so that is important to take note of. We have 2021. This Asia is the least, followed by Europe, followed by Africa. I don't know if there are many people, that much people in Africa, more than any part of the continent. I don't know. Like I said, these are just random numbers. Okay, for 2022, we have Asia, we have then we have Europe. Again, close. They're very close. If you see the value, you see, not very close, but visually they look very close, right? Right, they look very close. I'll take that back to 100. So visually they're very close. Let's explore this way. You see, very close, very close. But we know there's a difference between them. So 2023, we have this guy. Europe is listed throughout, sadly. Then followed by Asia is listed throughout. Then followed by Europe, followed by, that is, Africa. Okay, yeah, the legend. Now this is one of the challenges. I have to look at the legend again, then look at the charts, the series, and say, okay, oh, Africa is orange, something like that. Where can we put it instead to make it easier? What can we do? Well, when we're formatting the charts, we'll see that properly. Okay, so this is how to get an area chart. The next one is a donut chart. Now we know that anything that has to do with share, proportion. Now, one thing is important. The rule of donut chart is do not use when your series is more than 5. Less or equal to 5, that is the way. 6, that's an abuse. Okay, so make sure, don't be tempted. You see, it's just a thin line, just like it's just one more, and then little, one more, and then everything goes into chaos. Okay, so very important. You should understand that. Anything above 5, don't think about it. Don't be tempted. Don't be tempted. Leave it alone. Use a bar chart, okay, or use a donut chart. No, that's one beauty of a donut chart. All right, so I'll pick a pie chart first, and boom, we get this nice looking pie chart. Of course, there are no labels, there are nothing yet. In the formatting time, we'll look at that. Okay, so keep that there. So what if we have more orders? You know, let's see orders. Subsidiary. I'll just give them some random names. No, not subsidiary this time. Thank you. Auto downstream. Just see some downstream, upstream, mainstream, upstream, mainstream. Let me see. Did I format that header? I did not. All right, let's format that header. Okay, so this will not affect much. Good. So downstream, mainstream, and I will just take this out. Control minus. All right, so this is what we have now. In this case, let's say we want to see all of this using a pie chart, right? Also want to see this share. Now, what can we do? We can go with our pie chart, but this is chaos. This is chaos, right? Like I said, don't use more than 6. So what do? We can do something we call a pie of pi or a bar of pi. Let's look at how that works. Go to chart, change chart type, then you see a bar of pi. Very nice. A bar of pi. Or you can look at a bar of pi or a pie of pi. Anyone that works for you. Just stick to pie of pi. Hit enter. Nothing serious. All right. Now, we have how many slices here? 1, 2, 3. Let's start from green. Or let's start from this guy. So this is the last one. Blue, 2, 3, 4, 5, 6. So we have 6. We still got a problem, right? So because this is not supposed to be. And if we look at it, C is this guy. This deep guy, this deep black guy is who is this guy? Let's see this guy. Okay, let's see what's that guy. This company A. Is this other subsidiary? Right. Other subsidiary, right? Yes, that's other subsidiary. What's this guy? Market share. Okay, so that means this guy is meant to be E. Yeah, it's meant to be A. This should be upstream. This should be upstream. So if we look at this, this is downstream, mainstream, upstream. So we have these 3. Then others, which is the subsidiary. 1, 2, 3, 4. You just told them just calculating 1, 2, 3, 4, 5. So is this 6? Am I counting wrongly? Okay, let's look at that again. The green guy. 1, 2, 3, 4, 5, 6. Yes, that's 6. So let's start from the company A. Company A looks like this. What's company A? Let's look for company A. This is company D, company A. Okay, this is company A. Good. So company A, company B, company C, company D, others subsidiary. And who is this guy? Oh, yeah, my bad. So this guy right here is the total of all of this, so contributing to the share. You see, these things happen. These things happen. So this guy right here, of course, it's probably from you know that part where you've calculated, you already know what's going on. You're like, yeah, see it right there. This is what it is. I know. Thank you for your patience. Okay. All right. So this is the sum of this, which it was I calculated already. I was like, that's supposed to be no, this is supposed to be a perfect five and all of that. That's by the way. Now we want all the others category. For those who might be lost in the whole the little chaos that just went on. Let me delete this chart. Okay, let's do that again. Quick analysis. Go to charts. Select this. I don't want that. Change charts. Pi of pi. That is the way. Okay. Now we have this. Company A, company B, company C, company D, and this is the first order subsidiary, right? And then the rest category of the others are what we have here. So I'll close this first. Now, this should be fixed because 6 slices here is wrong, okay? But we'll keep that for the time when we're formatting the charts, okay? So let's leave that guy there. Let's just drag it a little bit. Let's keep it. That's nice. That's nice. Not bad. Not bad. Let's make this a little bit smaller as well. Okay, that is the way. Okay, now the last thing we want to do is a donut chart. For example, let's say we have this. I'll just duplicate this, or should I? Okay, yeah, nice. I know what to do. We'll bring this guy here, and then we'll say sales. Sales. Let's just put pound sign, and let's put the dollar sign this time. Okay, so this times 1,000, so that'll give us 1,000. Okay, we'll remove the formula. All right, the formulas are gone. Then we can do, should be, yeah, duplicate that. No, just say 20, 24. I checked this thing. No, I thought I have everything prepared, but it's okay. It happens. Okay. So let's just do John. Let's add. No, we won't add the full stop because May is just 3 as well. So I'll be getting a May. Okay, nice. So this is 2024, 2025, and this is the sales. So we want to use this for a pie chart first. Let's see how chaotic that will look like. Pie charts, boom. We don't want this. Not a good way, right? So what do? So we want to see the different shares for individual years, right? Or different sales for individual years in terms of proportion, right? Let's see which year we had our best sales, or which month of the year, I mean. So let's change our chart type again. Then we'll go to donut. Okay. So click OK. And this is not what we want, obviously. So I'll take that out. Then restructuring is the way. Yeah, the figure should be across those places, right? And then the sales should be okay. So that was 2025 sales. Let me just restructure. Like I said, very less thinking. Just trying to come up with something quickly. Okay, so this will be. Let's put this here. Drag this to this side. Okay. Put this down here. Then this will be cut, paste, paste. All right. Okay. Okay. So this will be products. Products. Of course, now you see our chart keeps updating as we change things, which is very cool stuff. Let's just do I want some random numbers as well, so that will be this minus rand between, let's say, just subtract random 100 to 500 from them. Okay, just give us that number, and boom. Okay, this is what we got. All right, so this will be our product. Let's pick from products. Okay, let's pick. Oh, we should just type products there. Oh, what product should we type? These are not products, so it's so cool to leave it there. Left. All right, products. So should we say mouse, keyboard, laptop. Oh, it keeps changing. Okay, yeah, let's remove the formula. Just notice that Control C, Control V. All right, gone. No more changes. Good. Yes, 5. Yeah. What else? Whiteboard. Okay, whiteboard. What else? Shirts. Let's just put shirts. Okay, trouser or pants. Okay, depending on whether you're American or British. Okay. So what's the last thing? That's tempting. What should I put there? Joystick. Yeah. Or iPen. Let's just do iPen. All right. So this is what we have, and let's pick that again. Now, of course, are there other ways to do that? Yes, no doubt. There's some better and advanced way to handle it, but just keep things simple and basic. Click on pi, click on this. Okay, yeah, that's the way. You can see we have what we want already. Okay, so take this out, take this guy out, and of course, it should still not be more than 5. So what's gonna go? What's gonna go? What is gonna go? Yeah, what should go? This should go 1. So 1 5 2 2. Okay, this 2 should go. I would control. So we have 1 2 3 4 5. Nice. So control minus, shift cells up. Okay, nice. So this is what we have, and yes, we have our data or our charts nicely formatted. Of course, this should be products. It should be product. It didn't take it for us, so just type that there. Oh, we'll do that in formatting, in chart formatting. Okay, this is what we have now, and this is looking good. This looks good. Insert. Just want to show you. See, for pie charts, 1 2 3 4 5. So what do you think it did for us? You see, it excluded the last guy. It's telling me I don't know how to do this. I cannot handle these. Okay, so you want to visualize something across multiple years, you can go with a donut chart. Now understand this. This is very important, that it doesn't necessarily mean you'll see data like this, right? Might be very rare to come across, but the most important thing is to know what to do when you eventually encounter a data like that. Okay, it's important that you have a good knowledge of what to do. You don't know when they come in handy, right? Come in very handy, quite handy, very important. So Let's move on. I'll delete this guy, and this is what I have. So we have 3 charts for donuts. Then we'll go to histogram. You remember what we said about histogram? Frequency distribution, right? Frequency distribution. Nice. Now, we want to group these people. We want to see how many people fall within certain age ranges. Okay. And how do we see that? For example, we might think of the manual way of doing this. Maybe between this age and this age, group them this way, this age and this age, group them this way, this age and this age, group them this way. But let's look at what the default value gives us. And when we are formatting our chart, we can now consider how to do it. Click on charts. Okay, we got histogram here. Let's click from here. All right. And then boom. This is what we have. So it grouped 18 to 39 for us, and then 39 to 60 for us. Okay, so that's what it did. Of course, can we adjust this grouping? Yes, we can. When we are looking at how to format our chart, we will look at how to input custom values, like, oh, we want this range, we want this range. You know, we look at that in details under formatting. But the most important thing is that we now have an histogram. Okay, so that's the most important thing. Now, we want to do for the scores, we want to group the scores as well, maybe 50 to 60, 60 to 70, 70 to 80. Now, one thing is sure, if we don't group ourselves, Excel automatically does some grouping for us that we can later change, like I said. But for now, we'll just go with the defaults. The major point is, in this video, you learned the kind of charts to use, and we are actually using those charts. We just want to see how to get those charts, put them in use, and what they look like. Okay, in the formatting part, we'll go in details more about, okay, how to adjust this, how to change something, how to put this there, add labels, and all of those things, right? So I've got more charts, histogram. Okay, so this is what I have. So you just did it in 2 groups, 55 to 76. All right. Just did it in 2 groups. Since Excel is 2 group defaults, not bad. We don't have a problem with that yet. Okay, just keep it somewhere there. And then we'll come and format later. Now on to the next, which is our waterfall chart. And you can see now, it's just, think of this as the capital of a person. So we have the starting revenue, which could be the capital, 10 million, COGS, 3 million, operational cost, 2 million, market spend, 1 million, right? Income from somewhere, 500, net profit eventually after doing some sales. This looks bad anyway. We have 4.5, right? Because this is 6, roughly 6, and then all we got is 5. Right? Not good. So you can see, I left a tip for you there. I said, if done right, it could be an executive level kind of storytelling thing. I think I mentioned that at the beginning. I don't know, I still have it down here. It's okay. All right. So how do we do this? To highlight the data. Do not forget, you can just click anywhere in your data, Control A, select all of it for you. Then we'll look at more charts, and you can see the guy here. So we have our guy right there. If you use a bar chart, what you get is all positive to the top or negative to the bottom. But this is not what we want to see. We want to see a sequential cumulative action, right? A sequential cumulative drop or action. Now oops, I eventually picked the wrong chart. Okay, let's just change it. Chart design, change charts. All right, this is what no, not this. This is Waterfall. Okay, now you can see how nice this looks. So this is a starting revenue of the capital of 10 million. After the cost of goods sold, there was a drop of 3 million. Then another drop of 2 million for operational costs, another drop of 1 million for market spend. Then we have what's it called? We have other income that came from somewhere, jump up by 500k. Then net profits, maybe after a certain time, they got 4.5, right? And you can see, as I said, it looks bad already. They have still not hit or gotten to the point of the starting revenue. So they're still short of 1 million. They're still 1 million short. Still 1 million short because they're sitting around 9 million. So they have still not gone beyond their capital. You can see how nice this is. So it's not just about seeing a profit of 4,005 or 4.5 for 4.5 million. Does it no, we're looking at this with respect to the capital. They have not exceeded the capital. That means they're still short. They are not profitable yet. See one chart, see how nice, and like I said, it's a very good chart. Just take your time with it, right? It can do a lot. So I'll just delete this. Okay, we'll keep this here for now. Then move on to radar charts. All right, I still have this here. So I removed it. So now this is what we have for performance comparison, kind of. Let's say, for example, some candidates, HR. This is good for HRs. They assess candidates across different skills. For example, Excel, SQL, Python, Power BI, communication, teamwork, and they graded them, right? They scored them over 100. Now they want to see who is the best. Now, if we pick this and do, let's say, bar charts, for example, a clustered column charts, you can see that it will be hard for us to compare. Now, this doesn't look bad, no doubt, right? So candidate A is this. Now, there's a lot going on here. We have to look back and forth, right? Because for Excel, the best candidate will be this guy, which is candidate D. What else? Candidate D. Okay, this is all candidate D. He is also good in teamwork, good in communication. Also, the best in teamwork, best in communication. What else? This chart doesn't look so bad, but it's just so spacious. It has to be wide. We can use this, right? We can compress it and do something like that. So let's look at how radar charts help us do a better job. Radar. You see, this is our go-to guy. This is the way. We'll click on that. Of course, we can bring our chart somewhere else. Now with this, we can easily say, I know it's looking chaotic, so I'll be forced to do some formatting now. Do I plan to keep that later? So the only formatting I want to do is just take out this guy, the values, right? Just want to take it out, so I'll just delete it. All right, and all these guys, the circles, I'll just delete them. All right, so this is cleaner. And if you look at this, we can tell, oh, who is the best in Excel? Candidate D. Best in teamwork? Candidate D. Communication? Candidate D. Best in, oh, why do I have double colors? Okay, it's blue, not double colors. So best in Power BI, what's the best Power BI skill? That's candidate C. Best Python, that's candidate B. And SQL, candidate C. So you can see how this helps simplify the visualization, right? So bring this down here, keep it somewhere there. Okay, let's keep it somewhere there. Not looking bad. So I want to do the same for these people. More chart, radar as well. Pick a radar. All right. So I'll delete this, take that out, delete this ones there, take them out. All right. So you can see now we have Bob, we have Charlie, we have Diana, we have Hallie. So who is the best in communication? Diana, easy peasy. Who is the best in leadership? Diana as well. Best in teamwork? Bob. Best in problem solving? That's Charlie. Is that Charlie? Yeah, no, that's Alice. Best technical skill? That's Charlie. You can see how Radar chart helps us simplify things. But be careful to use on dashboards, okay? They're quite compelling, quite what's the word? But you get the idea. Okay, let's just continue with what we have to do. Combo chart, right? Combo chart. Combo chart is where we can combine two or more charts, majorly or commonly a bar chart and a column chart. Bar chart and a column chart. So the first thing, we will not waste time, just pick this, go there, more charts, combo all the way down, combo charts, and this is what we have. Now, before we proceed, very important, if you look at this chart, you can see that there's a problem going on right here. So we have the months and we have sales, then we have profit margin. Now, considering the ratio of the profit margin to the sales, the gap is wide, very low, and that's why you see the line for profit margin lying flat on the ground. Now, Excel understands this and makes a provision for a secondary axis. A secondary axis will mean the primary axis is the one on the left, which is where sales are plotted. Now we want another axis for profit margin to be plotted, because by default it uses the same axis as this. What that means is that it's trying to plot, what's the highest here? 27 within this range, and 27 will barely appear because these are in millions, right? So what we can do is check this box and create another axis, and you can see now that makes sense. So we now have another axis for our profit margin. So this is the axis for profit margin, this is the axis for our sales value. All right, then we can hit OK, and this is what we have. Nice, right? Looks nice. Okay, so when we have this is the sales profit margin as well. It's only one point in time where we have, let's say, good sales, but the profit margin dropped slightly, and that could be due to maybe the costs at that point, maybe the costs, whatever it is, we can find out from there. Okay, so far we see that the more the profits, the more the sales, the higher the profit margin. That's what we have been seeing so far. So sales, profit margin, sales went up, profit margin went up, sales went up again, profit margin went up, sales went up again, but profit margin dropped at this point. So something happened in April that we might need to investigate or find out. But of course, we don't have enough data to know what is going on. And then the last one, profit shoot up again. Oh, sales shoot up again, profit margin, boom, jumped back up. Right, now for this, I just wanted to see it in different, I want you to see different use cases for it. So this is another one where we have targets and we have sales, right? Speak it again, speak our charts. Of course, we can have double line charts as well. But in this case, I want a line and a bar. Like I said, that's the most common one. And in this case, we just want the same axis, right? We don't want the separate axis because the figures are not so, far apart. So we don't want a secondary axis. If we do that, things get messed up. Okay, so keep it the same way. They're in the same unit. Okay, they have the same units, but these do not have the same units. This is in a currency, this is in percentage, right? So way different units, but these ones are in the same unit, so we'll keep them exactly the same way. Okay, so this is what we have. We say sales is the line, target is the bars. The target is the bar, target are the bars, target whatever. Okay, so what is this chart saying, or what is it saying? Because the most important thing about the chart is what you can communicate from the chart. I think I've not been doing that from the start, but let's continue. Now, this is telling us that this is the target. So if the line is above the bar, that means we exceeded target for that particular month. So that means in January we exceeded our target. In February, we didn't meet up with our targets. In fact, we didn't meet up with the targets for January. We went way low. So I think the manager is smart, so he decided to reduce the targets. Somehow, even though the target was reduced, the sales just showed up. The sales shoot up crazily, right? Crazily. So he felt like, oh, that's nice. So he pushed up the. Of course, this is a synthetic data. This is not a real data. Okay, we'll still tell our story. Still tell the story. So this is for April. We slightly increased the targets, but the sales dropped again. And the guy was like, okay, I'm not dropping the target again. The guy just pushed the target all the way up, and then the sales jumped all the way up as well. So nice, so nice. Okay, so this is what this chart tells us. If the line is above the bars, that means we exceeded the target. If the line is below the bar, that means we didn't meet up with the target. Very simple, straightforward, right? That's what we have right there. Last one, let's move to the last one, which is scatter plots. Okay, so for scatter plots, we have this. All right, that was formatted as well. Scores, this should be this way. This should be this way. Okay, this should be this way as well. All right. Don't worry, it doesn't really matter. All right, so this is what we have now. Scatter plots. What we want to see, we want to understand the relationship between the study hours and the scores of students. When we say we want to learn the relationship or want to study the relationship, that means we want to know if there is a correlation between the number of hours students study and the score they get. For example, if I study 10 hours, does that mean I'll score more? So that's the point we're trying to make. If I study more, does that mean I'll score more? So that's what we're trying to find out. And that's the point of learning or getting to see if any relationship exists between them, right? If any relationship exists between them. So what do we do? Now, before we jump into picking charts like the others, and that's why it was intentionally left for last, we want to mention some few things. Now, we said we want to find out the correlation. Now, something you must know is, yeah, my bad. All right, something we must understand is correlation is not causation. Oh, my bad, I forgot that again. All right, correlation is not causation. Okay, by the way, why am I getting the name error and name error? I'm just getting it, yeah? Like we say, even though the general thing is you must start a formula with equal to, but not always. For example, if I do a 5 minus 6, I get minus 11. So it automatically calculates for me. Of course, it added equal to the calculation. If I do a plus 5 minus 3, you see, it automatically changed the plus sign to what? Equal to sign, right? So whenever I use a negative sign or a negative sign or a positive sign, it assumes I want to write a function or a formula. So it automatically says, I don't know what you're saying, that's why I got the name error earlier. So how do you fix that? See, just add space. For example, if I want to do plus 5 minus 3, and I don't want this to be a calculation, I'll just add space, and then use it that way. So even if I start my formula with an equal to, and I do 678 multiplied by 5, I don't want this to be calculated, or I just want someone to see the formula, I'll just add space. And boom, it's just there. But immediately I remove the space. Whenever the space is gone, it calculates for me. So that's by the way. Now, back to our scatter plot. Scatter plot shows us what the relationship between two numerical variables. Note it has to be numerical variables. That means between numbers and numbers, okay? That means between two numbers, two series. So I want to find out if there's a relationship between this and this. I will say relationship. I will say what we mean by relationship is I want to see if there's a correlation between this and this. And we're saying correlation is not causation. What does correlation is not causation mean? Has it ever occurred to you that probably you were driving or you were walking and it seems as if a car is following you or a person is trailing you, and then you feel like, oh, okay, why am I being trailed? Why am I being tailed? All of those English. Why am I being monitored? Why am I being watched? And you kept walking fast, and it seems the person started walking fast, or the car started moving faster. And then you keep going, and then, at some point you almost be forced. Of course, there are two ways to it. It's that you pick race, you drive crazily, you go to some places, run away, or you're bold enough, you park, you wait, you want to see what's going on, you want to challenge them, right? Or you just wait and look at the person in the face. Are you following me? Are you trailing me? Whatever it is. So that's the point. So I'm going down. Someone is coming down. Now, in reality, or sometimes we'll find out that it just happened that both of you are going the same direction. So maybe after a few blocks, after a few miles, you just notice that, oh, the person takes another turn. Oh, fortunately, the person might not take another turn, and then you get to where you're going. Let's say you're going to a mall, and then the person goes into the mall as well, and then does this or shopping, or you parks beside you and enters somewhere, the same place you're going to. It just happened that way. That's what we call coincidence, right? Now, it simply means correlation, not being causation in this case, simply means because two things are happening simultaneously does not mean one is causing the other to happen. These two people that went the same way does not mean one called the other that let's go to this place. It just happened. There's a correlation, no doubt, they were going the same way, but it did not mean or hand does not mean the other person is who made the other guy. We have two other people now. There should be an actual person and then the other person. So it doesn't mean that one is making the other to go a particular direction. It just happened to be so. That's correlation. So that is why it's important that because two things are happening simultaneously does not mean one is causing the other to happen. For example, because the students are studying more and they are getting more score does not mean it is the study hour that is making them score more. Let's be more realistic. Well, we can't be more realistic than data anyway. So let's look at it in another context. For example, in cases like this, we could have some other factors that contribute to this. For example, mental health. Maybe they are not sick, sound health, right? All of those things can contribute to it. So, or intellect, right? Intellect. You can have someone study for 2 hours and still get 90, right? You get the point. So, because the study hour alone does not necessarily mean that is what is causing this to spike or hike. Is it hike or spike? Yeah, you pick the word. So, that means before we conclude in data that, oh, this, do you know why it's important? Do you know why we're mentioning all of this? Because if you, for example, if this is a report and you're telling them that, oh, if they study more, they'll definitely get more. Or let's use marketing email. Let's say if you report back that the more emails you send, the more sales you get. And then they start pushing in their money towards sending out more emails. And the sales is not getting better. You see, that's wrong. So that's why you must, there are other tests you can carry out to justify that, okay, yeah, I think this is actually really having a great impact on this, or is actually making this work, okay, statistically. Now, that's that, by the way. So correlation is not causation, because two things are happening simultaneously does not necessarily mean one is causing the other to happen that way. Okay, keep that in mind. Now, since we have not established that, we have types of correlation. Okay, all right, space first, then these types of correlation. Control A, Control B. All right, I can just tap this. Okay, so I'll say the first one is positive. I'll just do it this way, positive. Okay, still giving me that equal to sign because of the plus, you get it. Let me just drag this down. Okay, negative, we have negative as well. Then we have 0 or neutral. 0 or neutral. Neutral, just spell neutral again. Okay, neutral. All right, so this is what we have. These are the types of correlation that we have. Now we have something we call correlation coefficient. Correlation coefficient. It's a little stats. Yeah, I can just say it's a little stats. We'll tap that. I think I'll just do for all of this. Just do it this way. Okay. Now for this, we have positive 1.0 to 0.8. We have 0.8 to 0.6. We have 0.6. Okay, that was tapped twice. 0.6 to 0.4. We have 0.4 to 0.2. 0.2 to 0, or I'll just say to negative 2, negative 0.2, just keep it that way. Then we have then we have negative 0.2. Now this one performing calculation, so 0.2, negative 0.2 to negative 0.4. I'll say negative 0.4 to negative 0.6, negative 0.6 to negative 0.8, negative 0.8 to negative 1. Okay, so negative 1 or 1.0, consistency sake, 1.0. All right, this is what we have. I'll break this guy back. Okay, if I remove this, will it calculate? Yeah, it will, so leave it that way. So this is what we have. Now, what does this mean? What do they mean? Okay, what do they mean? This means that based on a formula we can use in Excel, we can determine the degree of the relationship, right? We can say, okay, fine. Even though there's a correlation, to what degree? Are they very strong, right? Which will give us that, okay, There's a possibility, there's a likelihood that this is actually boosting this or this is making this happen. A likelihood, right? Probability. All right. Now, this is we have some decided to change the figures. You can go online, you see some use 1 to 0.9, then 0.7 to 0.9, and 0. No, the numbers just keep going down that way, but they feel 0.9 should stay top. Okay, but what does this mean when you see this value? It means very, okay, some use perfect, so you can say perfect or very strong, positive. Okay, then we have strong, positive. Then we have weak, positive. We have very weak, positive. Then we have 0 or neutral, and of course you get the idea. So negative, oops, negative, okay, so this is what we have. Okay, it's lights, gray background, you know how it goes. Okay, so this is what we have. Now let's talk about the positive. What does the positive correlation looks like when the line is tending upwards? When it's going upwards, upward direction, downward direction. I think it should be direction. All over the place. Okay, all over the place. All right, all over the place. So this is what we have. Let's understand positive correlation. I just have to type all of that out quickly. Now let's understand positive correlation. Positive correlation means when variable x increases, variable y also increases, or when variable x increases or when variable x decreases, variable y also decreases. Because correlation happens between two variables. Okay, the relationship between two variables, so it can be variable a and b, variable x and y, variable w and x, or whatever it is, q and p, o and t, whatever it is. So for positive correlation, they go, variable x and y go the same direction. Both variables go the same direction. Now pay attention to this. Do not get lost. In my explanation, what I just explained is that when variable x is increasing, variable y is also increasing. When variable x is decreasing, variable y is also decreasing. Now when they are decreasing, it doesn't mean that the chart will show them in a downward direction. Okay, very important. So when you see that now, when we look at this now, and we'll plot this chart, you will understand what I'm saying. Okay, so both variables go in the same direction, either both upwards or both downwards. Very good. Now for the negative correlation, both variables variables go in different direction, in opposite direction. That's the word. Variables go in opposite direction. So when they are being plotted, they show downwards. That's how you know that, oh, negative. Why? It makes sense because positive shows upward, the top on on an axis, right? We have positive to the top, negative to the bottom. Does that make sense now? So for negative correlation, the direction is downward. You will see the data points tending downwards, and it means both variables are going in opposite direction. Okay, and of course this one, zero correlation, means all over the place is still all over the place. So I'll just bring that forward, all over the place, all over the place. It's as simple as that. All right, so this coefficient can help us now detect which category they fall into and how strong, what is the degree of the relationship in the category they fall into. So let's jump into it. This and this, click this, and click on the scatter chart. Boom, this is what we have. Of course, I don't want the line. Okay, so go back there and remove the line. Change chart type, select X and Y, select the first one, just keep it on the first one, no line. All right, so in what direction can you say this is going? In what direction would you say this chart is going? What is the relationship? Is it positive correlation? Is it negative correlation? Or is it random? That means there's no correlation between them. Well, how do we find out? You can find out by using one of our chart elements. Okay. Yes, I would have kept it to the formatting part, but this is also important, just like we did for radar chart. We need to do this as well. Click on the plus button. If you're on a Mac, you might not have the plus button. So just go up and then right your chart design and then all the way to your right again and click out. You don't have it. We have the contextual option. Once you click on that chart, okay, click on the chart. You go all the way to chart design, all the way to add chart elements, okay, on your right. And then you see the list of what you have, all of these things. All right. So click out. Well, for us, we have it. Yours will be here. So you look for trend line. And then click on the linear one, just a straight one. Right. That's the trend line. And for us, window users, we can just come here and go to trend line. Just check the box. You don't need to do anything. Just check the box. You can see now the box, the line, the trend line is showing us the direction of this. So this is a positive correlation. So to what degree? Let's find out using what? The formula. So I can just say coefficient, coef. And what's the formula? C-O-R-R-E-L, correl. Says it takes two array, right? The first one, just two. One, highlight this, and calculate it behind the scene for us. Close this. All right, so we have a 0.99. Of course, I want it to be two decimal place to be gone. That's zero. It's supposed to give me 0.99, but somehow I aggregated it. So let's keep it at 0.9. So that's very, very strong. And of course, for two decimal places, just as we have seen it, that's a 100%. That means strongly correlated. Strongly. That means there's a very strong likelihood that when the study hour increases, the scores also increase. Okay. Skip. All right. Now that is that about that. We have seen the correlation coefficient for that. I want something like this here as well. Just copy, paste. Good. Now let's do for this. Now we will not include this the same way I did not include this, right? It only works with series data, numerical value. Okay. So let's pick our numbers. Let's do that quickly. All right, nice. Control Q. Then we want to pick charts, sparklines. No, charts, more charts. We'll go there. And XY scatter. Yeah, that's it. XY scatter. XY scatter. Okay. And then we'll select the second one. We don't want this. This is treating them as two separate things. So this is the one we want. Now we hit OK. Nice. Now, the question is, what direction do you think this is going? It's the question. What direction do you think this is going? Do you think there's something going on right here? Is there a correlation? Is there a relationship? Well, it's easy to say it's random. You can just say, this is random. It doesn't make sense. But no, it's not random. So let's do something, add our trend line, and boom. Even though it's small, we can still tell that this is going upwards. Upwards. Okay, this is tending upwards. And of course, when we start looking at the formatting option, we'll see how we can cut out the noise. See all of this part that is empty. We can cut it out so we can focus on what really matters. Okay, so focus on what really matters. I'll just keep that down there. Keep it on top of this. And of course, our correlation coefficient as usual. Correl. Select the first array. Select the second array as well. Close that. Enter. So this gives us 0.67. All right, 0.70, which is that will fall into or fall under strong. All right, strong positive, which is okay. Strong positive. Now, the next thing we want to find out is, okay, we've done that. Just this a bit. So we have 0.7. Notice again that I did not use this axis, the last one. The same thing for this chart. I'll show you. Same thing for this chart. We didn't use this place. Okay, very important to know. Because we are concerned about the relationship between this and this, not necessarily the dates or the students, right? No, we just want to see if study hour increases the chance of getting more marks, okay, or more scores. Now, one beautiful thing about scatter plots is that sometimes it does beyond just showing us the relationship. It can also help us highlight an outlier, right? It can also help us highlight an outlier, and we mentioned what an outlier is when we're looking at was it errors? Yeah, one of those video series we explain what an outlier is. Yeah, I think on the data cleaning points. Yeah, data cleaning. So this now, as much as it doesn't seem very obvious, if I can use that word, we can tell that this guy is on its own. This guy right here. This guy is on his own. Seems everyone is going this way. It seems this guy is just there. Why? That's the highest. And by default, this is the marketing emails axis, and this is the sales axis. The natural occurrence is more marketing email, more sales. But for this guy, less than 800 marketing emails, but the highest sales. That's strange, right? So that raises a question. I want to say, okay, what's going on? What's going on? And if we look at it, that is this guy, 798 and 97. So, see the point? See. So, 798 marketing emails and 97 sales. That looks abnormal. Why? Why does it look abnormal? Why does it sound abnormal? Right here, we have 904 emails, but just 89 sales. 904. Do not forget that the value we had here was 798 emails sent, and we had 97 sales. We made 97 sales. Now, just from 904, which is one of the top number of emails, all we had was, let's look at the marks. Marks. Let's see. See, 922. So where's the guy? 922. See the guy. The highest number of emails only made us 93 sales. But somehow, 798 emails. Let's look at the minimum. I'm not sure. Of course, that should not be the minimum. Or that might not be the minimum. But we'll find out. Now, 777 is the minimum. And that's just about 77 sales. 75 sales. Alright. But how come that 798 emails? Oh, now we see. Look at that. Happened during this festive period, well, the day is not there, but December sales. Probably that's why there was a good shoot up. This point too, there was a good shoot up, right? 91, right? Even though the previous one, more emails. You can see that during this period, we have not as much emails as before, but we have good sales. And this is the mind-blowing one. Just 798 emails and then boom. No. Now we can see that, oh, this is what is going on in the data, right? You can see how just a single chart is helping us, is giving us direction to go to find out more about our data, right? Very nice. So that's that about the scatter plots. And this brings us to the last sheet in our charting techniques file. Of course, the next video will be about formatting, where we can make this chart looks very more nicer, more beautiful, good for storytelling, none of that. So we'll go to miscellaneous, and what do we have there? All right, tree map. This is for you, okay, an exercise for you to carry out. So for tree map, best for comparing large hierarchical data based on proportional size within a confined space. It has this good feature of bringing hierarchical data or categorical. For example, you have product category, you have subcategory, and you have the products themselves. You want to see the sales by the category and subcategory. This can easily do that for you. Sunburst is not bad. It's another good one for deep visualization, deep nested hierarchies to show the breakdown, right, from the outer one all the way down to the inner one. We have the funnel chart, simply put, for processes, very good for processes. Linear, I also put a linear, that's best for showing stages. That should be a linear. Linear is spelled this way, my bad. Okay, so best for showing stages in a linear decreasing process and identify bottlenecks. So it's a very good chart to use as well. But this is for you, miscellaneous charts. We've covered the key ones. Of course, these are key as well. Tree map is now becoming more used, okay, and of course we have maps as well. Let's go to insert. So you see maps, we have maps as well, field map. So yes, let's see, we covered most of all the charts, right? Okay, we have stock, surface, what else? Box and whisker plot. Yeah, this is also nice for detecting outliers, right? We've been talking about outliers. That is actually good for detecting an outlier. Okay. All right, so this brings us to the end of this video. If you stick to the end, thumbs up to you. That's the way to go. Just watch out for the next video where we'll now format this chart for proper use. So since we now have knowledge of pivot table, we now know how to use charts, we will learn how to format chart. That means we're now getting ready for our dashboard. Right, that's all for this video. See you in the next.